Okay, thank you. So, hello everyone. Thank you for joining us today. And I'll be start talking on the patterns of cloud scaling. And today you will learn how to decide what kind of cloud scaling option would be better for your applications, would be better for your system, depending on what kind of loads do you have, depending on what kind of application and the abstraction layers do you have. My name is Ilya Kaznacheev. I'm a technical leader at MTS Cloud, where we are building the Kubernetes as a service product. And also I'm a consulting cloud architect. I'm helping companies to run in the cloud, to live there and build robust and secure distributed systems. I'm a Google developer expert on cloud and also a certified cloud architect and a PhD. And let me start with basics and talk a little bit what is the scaling in general. Let us start from the classical monolithic system, like when you have a virtual machine or a physical machine with some kind of application, like it may be executable file, or it may be some kind of script like PHP script, which is running by the server or something like that. It's probably some kind of database there, like Postgres or MySQL or something like that. And probably there will be some kind of gateway, like Nginx or something else, hub proxy, etc., which will route the requests, do some kind of logging, authentication, maybe something more. And when your application is running, it's okay, everything on the same machine, there is no kind of problems. But at some point, as your audience grow, as your request rate grows, you may face some kind of issues, like it's not enough CPU, or it's not enough RAM, or it's not enough disk, etc. And the general solution to such kind of problem were to buy a bigger machine and run everything there. Previously, it was very easy because machines were cheap, machines upgraded really, really fast. So in a half of a year, you can buy twice powerful machine on the same price. So it was not the big issue. And when the time come and the resources are exhausted, you can just buy another machine. But the problem is now it will be more and more expensive. And if we are talking about load and resources diagram, it's kind of linear relationship. But when we will talking about the money, it's non-linear. And if we will combine both together, we can see that we can upgrade the same physical or virtual machine until some point where it will not be efficient enough. It will be too expensive to do that. And that's why distributed systems emerged, like microservices, etc. And we live in a world with distributed systems. So let's talk a little bit about that. And when we're talking about distributed system scaling, first of all, I'm talking about microservice scaling. The topic probably all of us love in one or another way, but still, it is what it is, and everyone faces microservice development and microservice support and infrastructure for microservices. So let's dive a little bit deeper and take a look on microservice scaling. Normally, there are kind of three different ways to scale a distributed application. One scale is horizontal duplication from one instance to many instances. Another is data partitioning from one partition to many partitions. And the third one is functional decomposition from monoliths to microservices, for example. Functional decomposition is when we take a monolithic application with different domains and split these parts into different deployment units, different applications. It may be functional decomposition, it may be kind of a domain-driven decomposition, but the main idea is we no longer have a single deployment unit. We have different deployment units with their own lifecycle and their own deployment pipeline. Horizontal duplication is when we just take one application and run multiple replicas of this. There are the same replicas, so there is no difference between them. The only difference is probably where they are running and how to access them via network. And the third one is data partitioning. It is a bit tricky, but the idea is that when we have some kind of data storage, for example, SQL database, at some point, the single database can no longer store all of the data. It's just too much. You cannot fit into the database, you cannot fit into the disk, or maybe some kind of network bandwidth issue emerges. So we split the data into several partitions by some kind of partition key or maybe some other algorithm. But the idea is that we no longer have data stored in the single place. The data is also distributed from this point. And let's move to the cloud. We'll talk about the basics. It's the same for on-premise systems, for cloud systems, for your home computers. So you can do all the same things at home on your laptop, or maybe you have some kind of server at home, or maybe a couple of computers. But when we're talking about clouds, the main reason why we use clouds is the how simple we can create and manage the infrastructure and the automation behind it, and the automation we can build on top. So let me talk a little bit about what kind of automation cloud providers give to you to make scaling a little bit easier. Let's start again with cloud basics, and cloud basics is virtual machines. So if we will look on the cloud infrastructure of any provider, let it be Google Cloud, AWS, Azure, Yandex Cloud, etc., even MTS Cloud, we will see services by layers. Layers like infrastructure as a service, as a basic layer. There are virtual machines, virtual disks, and virtual networks. Then we have platform as a service, where we may have such kind of things like Kubernetes, containers, managed databases, which are running on top of the own infrastructure as a service layer. And then we will have some kind of functions as a service, etc. So the virtual machines are the ultimate basics of any cloud provider, and not only cloud provider. You may go to the hoster or something else and buy virtual machines there. And normally we have a couple of virtual machines and a load balancer on top of them, which distributes the load, the requests, network requests between these machines. And there are different types of scaling available in the majority of cloud providers. Of course, manual scaling, so you can just go there and create a number of machines and then just say like, I want more machines. I want to have like 4 instead of 3, and a new machine will be created. Next one is scheduled. So you may create a schedule how you want your virtual machines to be scaled. Like, for example, if you are running some kind of sports-related news website, you may assume that during the top games, there will be much more visitors. So you may want to scale up your service a little bit, and you may schedule these events. The next one is dynamic. So when you say can set up like at the same you want to scale up your virtual machine group. Let's say when the CPU is above 80% or RAM is above 70%. So if this criteria will match, the cloud provider will create more virtual machines. And otherwise, when the criteria will be matched any longer, it will shut down some virtual machines. So it will save you money, and it will let you handle extra load. And the next one is predictive. Not any cloud provider has this kind of virtual machine scaling, but it's that the infrastructure of the cloud provider can learn what kind of load, what kind of changes and spikes in load do you have, and try to predict when to upscale or downscale your virtual machine group. Next, let's talk about the virtual machine group itself. So it's kind of a set of virtual machines with the same template, which is used to create or delete virtual machines for the same application. It normally has a minimum number of machines and the maximum number. So you will be always between these numbers. When there is more load, new virtual machines will be created until the number of machines will reach maximum. But when you have just less requests, extra virtual machines will be shut down, and you will be left with minimum number of virtual machines. And even if there is no load at all, you'll still be paying for this minimum number of virtual machines. Next, let's talk about the load balancer. Load balancer is a part of virtual network which distributes the load between any hosts. That may be virtual machines or containers or some kind of functions or something else. And it normally either level 7 of OCI model, HTTP plus maybe some kind of network routing, or L4 with protocols like TCP, UDP, etc. And there are also regional and global load balancers available. So global load balancers may work that way, that if you have your applications running in different regions, like in Moscow and Frankfurt and New York and Mumbai, the request will be routed to the nearest server. And also there are a lot of nice features available, like TLS termination, health monitoring, different balancing algorithms, some kind of anti-DDoS, and also private and internal networking features. So we've talked about the basics. And let's move to more cloud native stuff like containers. And the idea is basically the same. We have some amount of containers with network applications on them and a load balancer which redistributes the load among these number of containers. Normally it works the following way. There is some kind of orchestrator. We don't know which one and we don't want to know, but we know that this orchestrator manages containers, run a new container, deletes an old container, some kind of memory management, disk management, etc. And when we want to deploy a container, we create a Docker file, build an image, and then push the image to some kind of container registry. It may be a Docker Hub or cloud container registry of this cloud provider or of something else. And when the orchestrator sees the need to create a new replica, it just pulls the container image and runs it, and new container joins the load balancer group. So now the load from the load balancer, from the client, mobile client or web client or something else, will be redistributed between these 4 containers instead of 3. And when talking about containers, we cannot talk about Kubernetes. So let me dive a little bit deeper into the Kubernetes world. In Kubernetes, we have 3 types of autoscaling. So let me just start with the Kubernetes basics and then talk a little bit more about scaling options. Kubernetes is just a set of virtual machines with some number of master nodes, also known as control plane, and worker nodes where your containers are running. So master nodes normally have a fixed amount of nodes, like 3 or 5, and the worker nodes have amount which you choose when you create a cluster, or it may be a dynamic amount of nodes, but I will cover this a little bit later. So let's start with vertical pod autoscaling. Let's say we have 3 worker nodes and some containers running on these nodes. Nodes are actually virtual machines. And here we can see that we have pin containers, blue, green, and yellow containers distributed among these 3 virtual machines somehow. And Kubernetes handles this scheduling, this container distribution among the machines. So the utilizations of resources is pretty good. And when we want to do vertical pod autoscaling, that means that some container will gain more resources, more CPU and more RAM. So it will just get more resources. And yeah, it's often used for databases, for example. The second one is horizontal pod autoscaling. The same, we have some number of virtual machines, but when the load increases, we just create more replicas. So again, we take more resources, but instead of create bigger containers, we create more containers. And that's actually more flexible than the previous one. And the next one, which is not available in vanilla Kubernetes, but available on cloud providers, is cluster autoscaling. That means when we reach some point when our existing virtual machines, our existing worker nodes can no longer fit all the load of these virtual machines, we will create another virtual machines. Actually, cloud infrastructure cloud provider will create a new virtual machine for you automatically. So it will work like magic for you. And then the load, the containers, will be distributed to this new Kubernetes worker node. And again, if we want to do task scaling, but we normally don't want to, it goes automatically depending on the CPU, RAM, or any other variable. And when that happens, the cloud provider marks one of the nodes as node for deletion, and then starts to move this node to different nodes, and eventually shuts down this node. And that's how it works. So we covered two main layers of cloud infrastructure: infrastructure as a service and platform as a service. So let us move to the next layer called function as a service. They may have different names like lambdas on AWS, cloud functions on Google Cloud, or just functions on Azure. But the idea is that you simply upload your code into the cloud, you set up triggers and actions, etc., and it just works. You don't have to think about virtual machines, nodes, administration, etc., etc. It just works. And when event happens, it triggers the function. The event can be either HTTP request or database trigger or queue message or something else, and it will trigger the function. And the nice idea behind the cloud functions is that it auto-scales magically and very, very fast. So depending how many events happening during the time frame, it will span more and more functions. So if you have more events, more functions will be started. More and more events and more functions. So it's basically most flexible auto-scaling mechanism available on the cloud. And another nice feature is when there is no events, it will be no functions. So cloud functions easily scale down to zero, and you will pay nothing when you don't have any incoming requests, any events in your system. So we basically covered the stateless options for the cloud, and it's pretty simple to auto-scale stateless services. You just create more services, or you create bigger services instead, bigger applications, bigger containers, etc., etc. But it's still not the real case, because in the majority of infrastructures, the real deal is stateful. For example, databases or something else. So let's say a couple of words about this. It's a bit tricky, and we'll start with service, aka data storage, like S3, for example. When we have S3 bucket, we just put binaries there. It may be images, video, any media files, texts, etc., etc. It doesn't matter. We just put binaries there. And in the majority of cloud providers, the buckets just auto-scale automatically. You don't have to do anything. You can just put more and more and more data into the same bucket, and it will upscale for you without any extra work required. There is actually a trick when the bandwidth of the bucket may be limited, so you will have to create new buckets, but probably if you don't have the system under the heavy data load, you will not face this issue. Let's move on and talk about relational databases. For relational databases, things are a little bit more difficult, and you cannot just easily make it bigger, but some clouds like AWS allow you to upscale the disk for the database. Of course, it will not always help you to fix all of the issues. For example, if you have limitations on CPU and RAM, it will be also difficult to just upscale it. You have to recreate it. And you just can't have an unlimited disk for your database, but still, it's a nice option when you're using database. And yeah, you just need to upscale the storage a little bit. But as we talk about NoSQL databases, they are normally run in a cluster. So there are amount of nodes, amount of virtual machines when the different partitions of the database running. And when we want to fit more storage into the database cluster, we just create more brokers. Or it would be better saying that cloud provider will create them for you. So you just don't have to do anything. The cloud provider will create more and more brokers and will redistribute the amount of data between them. And it's very nice because you don't have to like try to create the whole infrastructure beforehand when you don't know the load patterns, when you don't know how many data will you store. And cloud provider will help you to achieve this by magic under the hood, magic of horizontal database scaling. We covered databases, and let me say a couple of words about MapReduce, like Hadoop or Spark or something. So the infrastructure is pretty similar to Kubernetes cluster or any other cluster. There are some kind of management nodes or controller plane or something like that. So there will be one or more virtual machines which managing the cluster itself, and the amount of worker nodes where your calculations will take place. And the scaling is similar when you don't have enough virtual machines to do all of the calculations. Cloud provider will simply run another virtual machine in the same cluster, and you will get more calculation resources without doing any kind of dirty work. You just can either do a couple of clicks and upscale your cluster, or the cluster will even do everything for you automatically. And as for queues like SQS, Kafka, etc., pops up, the same works for message brokers. You normally have some kind of cluster of several brokers, and when you have to upscale the cluster, will simply set up it to work together with other nodes in a cluster, and it will magically give you more resources to land the data, to land the messages into the cluster. And at the ending, I would like to say a couple of words about, let's say, super services. So each cloud provider has a number of its own like rockstar services, like in Azure, in AWS, in Google Cloud, like Cloud Spanner, Bigtable, Firebase, DynamoDB, Cosmos DB, etc. And what's important is that these services already have some kind of auto-scaling inside them, but you will not see this kind of auto-scaling. So you will not see the number nodes in the database. You will not see scaling options. It will just work automatically for you. So you can just put your data there, and the cloud provider will do the magic for you. And you will just pay for the amount of resources or the amount of requests, and everything else will just magically happen inside of the cloud provider. And that's actually why I like cloud providers, because they try to free you from the administration work, for database administration, for infrastructure administration, and give you just an API to use your cloud infrastructure, to use your databases, to use your container orchestrator, to use your, I don't know, something else, and you can simply don't think about all of these topics. It will magically happen for you. And yeah, that's all for today. Thank you for your listening, and I would like to answer your questions.
Yeah, thank you very much for the speech. So it's really interesting for me, and I noticed some important, so new interested information for me, of course. We have not so more questions, but we have one more. The question is, what do you think? Do the team should have a separate DevOps engineer, or team should be able to distribute it on servers? I can repeat. Ilya, are you with us?
Can you repeat the last part of the question, please?
Yeah, sure. Looks like you have
Because
a
the connection is not
internet
very good.
issue. Can you hear us?
Yeah, I can hear you, but I missed the last part of the question.
Right. Sure. What do you think? Do the team should have a separate DevOps engineer, or team should be able to distribute its own servers?
So it depends. Thank you for the question. First of all, it depends on the requirements and on the needs. So if you want to have more control on your infrastructure, like when you want to use specific operation systems or a kind of drivers on top of the operating systems, like for 3D modeling or something like that, you probably would like to choose more low-level options like infrastructure as a service and manage everything by yourself. So the cloud provider will give you the basic infrastructure, and then it's your turn. You will set up the operation system, you will patch it, you will upgrade it, you will install all of the system libraries and requirements, and your applications will manage a DevOps engineer or probably a DevOps team. But on the other hand, if you don't have to do this, if you just want to run your application in the cloud, if your application is kind of cloud native, like it's stateless, it's containerized, you can just put it into container and set up something like Google Cloud Run or Heroku, when you just run container in the cloud infrastructure, and thus you don't need a lot of DevOps work to do. You have to set up CI/CD pipelines, you have to set up some kind of repository, and that's basically it. And if you just want to run your code in the cloud, you can use any kind of cloud functions and just don't have DevOps at all. But normally you will not have so much control on your cloud infrastructure. So it depends on the needs of the product and of the company itself. So some companies are forced by laws, by government regulations, for example, to like run some kind of audit logging on the virtual machine. So then the cloud function is not the option for them. But I would say that if you're a startup, if you're a young company and you don't know how many users you will have, how big will be the load and the amount of storage, try to start with options with less administration, like Kubernetes or even containers or even cloud functions. And then when you will feel your limits, when you will understand the scenarios of data flow through the system, you can play a little bit with that and finish with infrastructure as you want it to be, like Kubernetes-based infrastructure, which is best option for today, I think, or even a virtual machine-based infrastructure when you will have more control, but you will be 100% sure why you want to have such kind of control. Yeah, that's it.
Great. So your answers look like a small speech anyway. Next question is, do you have a site reliability engineer in your team?
We don't, but as we work with a kind of DevOps domain, so inside of the cloud provider, our clients are mostly DevOps engineers. We first know a lot on this topic, and we implement SRE practices in our daily work. So we don't have such kind of team of SRE engineers. We don't have such kind of team of, I don't know, something else. We just all work on this topic. We try to implement different practices like disaster recovery plans, like something else, like like SLAs and all of this SLA, SLO, and SLI related stuff to make our more and more pleasant for customers. And that's not only just a thing that we wanted to do this because it's a fancy thing. It's, Google does that, and that means we also want to do that. No, it's just necessary, because if we will not do that, we just will be unable to build reliable enough infrastructure to meet our requirements. And our requirements our main requirement is 4 nines of infrastructure and service availability and the process success. So yeah, we do a lot of work on this topic to make the whole infrastructure reliable and disaster tolerant. Yeah, that's it. So if you have really big, really strong requirements on resiliency, on fault tolerance, or on disaster tolerance, you will be forced one way or another to implement SRE practices, and not only on the infrastructure layer, but also on application layer. So these two parts always work together.
Right, great. Next question.
Hope I answered your question.
Looks like it. Is how do you monitor your service in the cloud?
Okay, so again, there are several options. First option is to use what cloud provider gives you, and the majority of providers have some kind of monitoring solution, monitoring product for you. For example, in Google, there is a set of observability tools for logging, for monitoring, for tracing, etc., and you can just use them either by native API or by means of some kind of standard like OpenTelemetry. The same goes for AWS, the same goes for Azure, etc. Another option is to use SaaS product like Datadog, like there are a lot of them, and they're pretty good actually. So there are many players on this market currently, and some of them gives you really nice opportunities like machine learning to predict some kind of will help you to analyze all of these metrics, all of these traces and logs will be transmitted a little bit more. And the third option is to run your own observability infrastructure like Ilka, like Jaeger, like something else, Victoria Metrics, and set up your own serves like Grafana, etc. This works better for bigger infrastructures because it costs you more. Again, it gives you more control, but costs you more labor. But you can be more flexible in exchange of more work and more possibility to do something wrong. So it's up to you to choose. Again, when you start in your company, when you start in your product, I would advise to use existing cloud options and then move to something else.
Right. Thank you very much. I have one. So we don't have any questions from our audience, and I would like to ask you my own question. And the question is how to handle errors and do not go crazy of it. I mean, we have lots of service in the cloud, and as well they provide for us lots of errors and how to handle all of them.
That's a great question. Thank you for that. And I would say that errors is something related to your code, your tech stack, let's say, but how we handle them is related to organization and the organizational culture itself. So since we run our applications in some unknown environment, like somewhere on the remote server, on the remote rack, in the remote data center, we don't have direct access there. So even if we run on virtual machine, we can log in via SSH and see logs. But when we run in Kubernetes, we may be limited in options. And when we run just containers, the options will be even less, even more limited. So in this case, you will still have logs, you will still have tracing if you will implement it, and monitoring. But to be able to handle the errors you have to build right processes. Like when something breaks, you just don't have to go crazy, run around and try to fix something fast. You have to understand what to do in each case. Some things like alerts, like monitoring and distributed tracing will help you. First one will notify you probably before the bad things happened, and the second thing, the distributed tracing will help you to localize the error faster. Like you can just open the trace and find in which service the error is. But to be able to fix them like a pro, you have to again implement SRE practices inside of your company. Some practices are harder to implement, but some of them are much simpler, like post-mortem. It's the practice when when something breaks and you sit together with your colleagues and try to understand what happens, why, and how to fix that. But what is most important, you don't want to find who is responsible for this, because you are the team. You are everyone in the same boat. So it's not important who broke that. It's important how to fix that and set up a bunch of tasks to fix each part of this big failure. So that's where you can start. Try to learn about these SRE practices. Try to implement as much practices as you can. And during this process, a lot of errors will just gone because you will have right processes, which will help you to eliminate the majority of problems.
Great. So it's wonderful answer. I'm really grateful to you. Anyway, thank you very much for your speech, interesting knowledge you shared to our audience. And I want to say, try to create a new interesting speech for our further meetups. And good luck in your next investigation in from how to say in a cloud world.
Yeah, thank you. It was a pleasure for me to participate.
Yeah. Anyway, thank you very much. So we'll go further for the next speaker. Bye, Ilya.
Bye.